Hello. Welcome to the first video for Summer Institute Chemistry, or if I decide to use these during the regular school year, if we're not back to face-to-face instruction, welcome to Chemistry 1 Honors. They always say that if you're doing these screencasts, students do better if they can see a picture of who you are. So here you go. Here's my introduction. Apparently, even though I'm only 52 years old, I was born in 1947. And apparently I was born as a full 8-year-old, 9-year-old child with a chemistry set. Apparently, 10 years later, here I am teaching at South Brunswick High School. And then in 2008, I portrayed Walter White in the hit TV series Breaking Bad. Here I am time traveling back to 1949 at the height of my powers. Apparently I am burning a student research paper, and you can see I'm really gleeful about it. And then here's a picture of me the day, our last day that we had school before the COVID-19 shutdown. And after worrying about coming up with videos for Summer Institute, here's what I look like today. So there you go. There's my introduction. And we can go ahead and start. All right, so the introductory chapter, they always start out in science books with two things, one of which, what on earth are you studying? And the second is, hey, let's use the scientific method. So we'll start with what is chemistry, and your book gives this definition for you to memorize: a study of the structure and properties of matter. So in other words, what chemistry is a study of the materials that we use, and use them hopefully to create technology, to make things that make our lives better. Really two types of study. One, human beings are naturally curious, so chemistry is a study of matter just for the sake of understanding it. And the second is to apply it to produce something. So I always say that, hey, chemistry is take chemical A plus chemical B, react it, and then have it blow up and kill you. Or take a different chemical A and a different chemical B, and let's smack it together, and I don't know, let's make a laptop computer out of it. You know, the idea is taking materials, putting together. You know what would be a good example? A plus B produces, right, a vaccine for COVID. That would be really good. Anyway, but that's the idea of chemistry. Let's study the material science, how to make things. Now, unfortunately, when you look at Chem 1 in high school and college, your introductory courses are all what they call survey courses. There are a lot of topics, and you never get to really apply them to anything. And it's the application that's the most interesting. Like, for instance, I'm an organic chemist. So, you know, my focus is on biochemistry and the production of medicine and therapies for people. I find that extremely useful, whereas if you have Dr. Dabari for AP Chem, his doctorate is in material science, so he made things like glass, that sort of stuff. Anyway. And then they get into, all right, science. Science is an algorithm, a step-by-step process, a way for us to understand the world. And the idea of having an algorithm is to remove bias. I always get concerned when scientists start to espouse their political views, because as scientists, we're not supposed to give our political views. What we're supposed to do is we're supposed to gather data, gather that evidence, and then report on it. You know, hey, here's a piece of material. It is 60% carbon, and it is 40% zinc. And then that's it. Not to make statements about it, good or bad. You know, we have evidence for global warming. So you produce the evidence, you publish it, and that's it. Not whether it's good or bad. That's up to politicians. That's up to activists. That's really not up to scientists. But it is important to have scientists that are willing to advocate for what they think is right. So we're going to go over scientific method. And then the idea of scientific method is to create technology. In other words, let's make things that people can use to make their lives better. Here's the thing with scientific method, and I know you had it in middle school. All survey classes start with scientific method. Hey, first let's make a hypothesis, and then we're going to make observations based on that hypothesis to test it. And then from the data, we're going to develop theories, and then we're going to keep repeating this process. Two things that are important here. One, the most important thing is this: repetition. As we get better technology and we're able to get more precise data, we're able to develop better ideas about what's going on. So our understanding of science is continually evolving and changing, growing. The second thing about scientific method that I want you to understand, that this is not draconian. You don't have to follow all these steps for every single thing that you do in science. For instance, let's say we go into the lab and we're trying to find the specific heat of a certain metal. So we have an unknown metal and we want to know some of its properties. Well, let's say the property is, for instance, instead of specific heat, something that you're more familiar with: density. All right, so we know that density is mass divided by volume. So we're going to find some way to come up with a precise and accurate measurement of both quantities and then figure out what the density is. Once we know the density, we can identify the material. Pardon me. But we're not going to hold up the object and make a hypothesis and say, oh, I'm going to hold this rock and I'm going to make a hypothesis that the density is, I don't know, 6.125 grams per milliliter. It's not appropriate. I mean, certainly analysis of a material is an important thing to do in chemistry, but it doesn't require making a hypothesis. So I want you to understand scientific method is important. It's a step-by-step process that allows us to eliminate bias from our findings. However, not all of it applies to every single thing that's done in science. So, chemistry. What is it? Look, there are 14 million compounds on our planet, and 8 million of them are natural, and 6 million of them are man-made, plus you have about 115 elements, and then you have combinations called mixtures. So there are millions and millions of combinations of materials that you can put together. So a couple of things I'm going to tell you about chemistry is, what is chemistry? It's vastly related to so many different things. And there's a list of them there on the slide. But I also want you to understand that again, we're not getting into the application very much. And with 14 million compounds, no one's going to be an expert. I'm not an expert. I am an intermediate. I have an education in it. I have experience, over 20 years of teaching it, but I'm certainly not an expert in it, even in the things that I love, like organic and biochemistry. Second thing is to be patient. There are a couple different ways to teach chemistry. Some schools start with, hey, this is a atom, and the atom has protons and neutrons and electrons, and then they start building out from that. Another way of teaching it is the way that we're going to do it, where we start with the naming systems, and that way we're able to identify materials in the lab. In your case, if the summer, virtual labs at first until we become back on a face-to-face basis, so that you can function well in the lab. And then after doing that and what's called the stoichiometry, the mass and mathematical relationships of it, then you go back and you do the theory. So you can do the theory first, then the mathematics, or the mathematics first, then the theory. I've done it both ways, and when I've done it both ways, I get equal success. So the purpose of doing it the way I'm doing it, if you notice in your guide, we go from chapter 1 to chapter 7. The reason why we're doing that is because it allows students to function in the lab better. All right, so I can't teach you everything in one day. In the Zumdahl text, and this is the only chapter where I use Zumdahl in addition to the Merrill Chem book. I attached it in one of your posts. What are the 5 traditional areas of studying chemistry? How are pure and applied chemistry related? Those are good questions. And then we're going to finish up with, after we go over that, we're going to finish up with why should we study chemistry, and then that'll be it for this video. So I try to keep it around 15-20 minutes. All right, 5 studies. The 5 areas of study is organic chemistry, inorganic, biochem, analyt, and physical chem. And I'm going to give you some notes on each. All right, so you can stop the video at any time, of course, and take notes on this. What is organic chemistry? My favorite chemistry. Study of covalently bonded carbon compounds, except for carbon dioxide. They don't consider, many professors do not consider that as part of organic chemistry, nor do they consider carbonates, but almost all of the carbon compounds are considered organic compounds. Again, I find it fascinating because not only are organic compounds builder materials, we can build plastics and things from them, but they're also the foundations of biology. And medicine is in biochemistry is what I find fascinating. So when you look at things that you learn about biology, like fats, proteins, carbohydrates, DNA, RNA, they're all builder molecules. So really, organic compounds come down to two types: builder materials and burning materials for energy. But again, it is my favorite study in the five branches. So I'm always going to take that sort of point of view. When I go through this stuff, I'm going to have a lot of biology examples. Inorganic chemistry, again, still closely related to biology, but more like the water cycle, nitrogen, and how nitrogen forms smog, pollution, that sort of thing, the atmosphere, composition of rocks and minerals. Another way of thinking of organic chemistry would be the study of the elements that are not carbon related. Right, so biochemistry is going to be an application of organic chemistry. These are going to be the chemical reactions and properties that affect life and sustaining life. Physical chemistry. Physical chemistry is about the properties of materials and how we can use those properties of those materials in order to create technology. And analytical chemistry. I always say analytical chemistry is what on earth is this thing and how much is in it. So analyzing soil samples for pollutants, for instance, would be a good application of analytical chemistry. All right. One of the things I like about the internet is I'm always amazed that people think that when you have a public forum, you have a right to privacy of your material. I stole all of these diagrams a couple minutes ago off of the internet. The only thing is, if you're going to use them in a paper and you're going to publish things as your own work, you should always cite them. Here, I'm not going to cite them because I'm not saying that this is my own work. I'm using this for educational purposes. So again, chemistry, why is it so fascinating? I mean, look at all these things that it relates to. They consider chemistry to be a central science, which means that all other sciences have some sort of application of chemistry at their core. And you don't have to know all of these different ones. I'm just showing you. So again, all different types of jobs based on chemistry. If you go into medicine or environmental cleanup or environmental study, chemical engineering, how to make products, forensics, diagnosing the cause of death or something in a patient, that sort of thing. Again, many, many different aspects of jobs that are related to chemistry. And we went over the five branches of chemistry, so I'm not going to bring that back up again. But I like this little diagram, chemical engineering. Now, do understand that there are two major areas for jobs in chemistry and chemical engineering. Actually, three, I'm sorry. One, pardon me again, I have allergies. One is in Atlanta, Georgia. Another one is in San Jose, California. And the third one is actually in central New Jersey, where your parents live. And I know that many of your parents are involved in careers that are related to chemistry or involve chemistry. So, a good thing about studying chemical engineering is that when you're young, you always feel like you want to move away from your parents and be independent. But after you're away for a little while, you realize that your parents were pretty wonderful, and then you want to move back home. And central New Jersey is one of those places where you can get a job in chemistry. And again, lots of different things. Material science, mathematics, communication, ethics, computers, all those things can be related to chemical engineering. And then finally, I thought this was interesting as well. Even if you break chemistry up into the five major studies, it's sort of like being a doctor. Every doctor has his own or her own speciality. And even in biochemistry, you can break biochemistry up into many, many different things. Immunology right now, that would be good because, you know, we need a vaccine. So I'm going to circle that one right there. That one's important. So hurry up, get a job, and get me a vaccine so I can get back into the schools. Hey. All right, so what do you have to know then for a test? As far as the five major branches, just be aware of what the five major branches are and be able to give some examples of what's studied in those five major branches. Pure science and applied science. I talked about this earlier. Pure science is studying science using scientific method for the sake of understanding the universe. Human beings are very curious creatures. Applied science, to me, that's what's interesting. Taking that knowledge and producing something that we can use. And again, I'm going to keep saying vaccine. We're going to use it to make a vaccine. And why study chemistry? Because it is central to so many other sciences. We have some good jobs right here in central New Jersey. And the last thing I didn't mention is our duty as citizens when we vote. It's important to understand science so that you don't get caught up in some of the rhetoric, like, for instance, what's going on with social distancing. Social distancing is not political. Social distancing is science. We want people to be healthy. We want to save their lives. All right, so that's the first part. Again, introduction, a lot of review. These first couple of videos will be like that, but I promise you it will get harder. So thank you very much.